with narration segments, examples, and explanations to make it flow like a film. Title: Artificial Intelligence, the Dawn of Intelligent Machines. Futuristic visuals, robots working alongside humans, digital data streams. In a world powered by data and driven by innovation, one technology stands out as the harbinger of a new era: artificial intelligence, or AI. It is a technology that once lived only in the imagination of science fiction writers, but now permeates our daily lives, shaping the way we work, communicate, and even think. Cut to historical footage of early computers. Narrator: artificial intelligence is not new. Its roots stretch back to the 1940s and 1950s, when visionary scientists began to dream of machines that could think. Among them was Alan Turing, often called the father of modern computing. In 1950, Turing asked a simple but profound question: can machines think? This question laid the foundation for what we now call AI. Seen archival photos of early AI researchers like John McCarthy and Marvin Minsky. In 1956, the term artificial intelligence was coined at the Dartmouth Conference by John McCarthy, a computer scientist who believed that machines could simulate any aspect of human intelligence. Alongside pioneers like Marvin Minsky, Herbert Simon, and Alan Newell, McCarthy launched the first wave of AI research, focusing on symbolic reasoning and logic-based problem-solving. Scene: visuals of old computers, punch cards, and early robotics. Narrator: early AI research was focused on narrow tasks. Programs could solve algebra problems, play chess, or prove mathematical theorems. But these systems were brittle. They lacked common sense and could not adapt to new situations outside their programming. Researchers soon realized that intelligence was far more complex than initially imagined. Scene: transition to modern AI, neural networks, and data centers. Narrator: the next breakthrough came with the development of machine learning, a method where computers learn from data instead of relying solely on pre-programmed rules. This approach was inspired by the human brain. Artificial neural networks designed to mimic the way neurons fire and connect allowed machines to recognize patterns, make predictions, and even understand language. Cut to visuals of AI applications: voice assistants, self-driving cars, medical imaging. Narrator: today, AI powers everything from the voice assistants in our phones to the algorithms that recommend movies and songs. Companies like Google, OpenAI, Microsoft, and IBM have developed AI systems that can write text, generate images, play complex games, and even drive cars autonomously. The possibilities seem endless. Scene: animation showing how AI works, layers of neural networks processing data. But how does AI actually work? At its core, AI relies on data, algorithms, and computing power. Machine learning models are trained on massive data sets, learning patterns and relationships within the data. Deep learning, a subset of machine learning, uses multiple layers of artificial neurons to recognize highly complex patterns. For example, a deep learning system can analyze thousands of medical images to detect cancer more accurately than some human doctors. Seen examples of AI in real life. Consider self-driving cars, which combine sensors, cameras, and AI algorithms to navigate roads safely, or AI-powered chatbots, which understand natural language and provide customer service at scale. In healthcare, AI helps researchers design new drugs and predict disease outbreaks. In finance, it detects fraudulent transactions instantly. The reach of AI is vast and growing every day. Scene: transition to benefits and impact. The benefits of AI are enormous. It increases efficiency, reduces human error, and opens doors to innovations previously thought impossible. AI can analyze vast amounts of data in seconds, enabling breakthroughs in science, medicine, and engineering. It also has the potential to democratize knowledge, bringing advanced technology to regions that previously lacked access. Transition to challenges and ethical concerns. Yet, AI is not without challenges. Ethical questions loom large. Who is responsible when an AI system makes a mistake? How do we prevent bias in AI algorithms that can perpetuate social inequalities? And what about privacy? Every AI system requires data, often personal and sensitive, raising concerns about surveillance and misuse. Visuals of robots and AI in industry, mixed with protests and debates. Narrator: moreover, there is fear of job displacement. As AI automates routine and repetitive tasks, millions of workers may need to reskill. But history suggests that technological revolutions, while disruptive, also create new opportunities, new industries, and new careers. Scene: future-looking visuals, AI, human collaboration, smart cities. What does the future hold for AI? Experts predict systems that are more adaptive, explainable, and collaborative. Researchers are working on artificial general intelligence, AGI, machines capable of understanding and learning any intellectual task a human can. While AGI remains a distant goal, incremental progress continues at a rapid pace. Scene: AI in space exploration, environmental monitoring, and humanitarian aid. Narrator: AI may help us explore the universe, fight climate change, and respond to global crises with unprecedented speed and accuracy. By augmenting human intelligence, AI has the potential to tackle problems that were once considered insurmountable. Closing scene: montage of AI in daily life, humans interacting with machines, innovations emerging. From humble beginnings on paper and punch cards to sophisticated systems capable of learning and reasoning, artificial intelligence has come a long way. It challenges us to rethink what intelligence is, reshapes the world around us, and offers a glimpse of a future limited only by our imagination. Narrator: as we stand on the threshold of this AI-driven era, one thing is certain. The machines we build are no longer mere tools. They are partners, collaborators, and perhaps
Here's a
the
full
architect.
version.
Title: Deep Learning, Teaching Machines to Think Like Us. Opening scene: futuristic visuals, glowing neural networks, machines processing information. In the digital age, one branch of artificial intelligence has emerged as a revolutionary force: deep learning. A technology inspired by the human brain, deep learning is transforming industries, medicine, science, and even the way we perceive intelligence itself. But its story begins decades ago in the minds of mathematicians, computer scientists, and visionaries. Scene: black and white footage of early AI labs, computers with punch cards. Narrator: deep learning is rooted in the concept of neural networks, first theorized in the 1940s. In 1943, Warren McCulloch and Walter Pitts introduced the first mathematical model of a neuron, showing that networks of artificial neurons could, in theory, perform logical operations. Their work laid the foundation for thinking about machines that could learn from experience. Seen: early experiments in AI, researchers adjusting weights on simple neural networks. During the 1950s and 1960s, computer scientists experimented with simple neural networks called perceptrons, capable of basic pattern recognition. But progress was slow, computing power was limited, and the networks could not handle complex problems. By the 1970s, interest waned, a period known as the AI winter. Yet beneath the surface, the dream of learning machines never died. Scene: rise of machine learning in the 1980s and 1990s. Narrator: in the 1980s, the invention of backpropagation, a method to efficiently train neural networks, reignited interest in learning machines. Researchers like Geoffrey Hinton, Yann LeCun, and Yoshua Bengio advanced these networks, showing that layered networks could solve more complex tasks than ever before. This layered approach is what we now call deep learning. Scene: animation showing multiple layers of artificial neurons. Deep learning works by stacking multiple layers of artificial neurons, each layer extracting higher-level features from data. For example, in image recognition, the first layer may detect edges, the next shapes, and subsequent layers may recognize complex objects like faces or cars. This hierarchical learning enables machines to understand raw data in ways that traditional algorithms never could. Footage of modern GPUs, data centers, and massive datasets. However, deep learning's rise was powered not just by ideas, but by technology. The explosion of data in the 21st century, combined with faster GPUs and cloud computing, allowed deep networks to be trained on billions of examples. Systems that once took months to train can now learn in days or even hours. Examples of deep learning in action. Deep learning is everywhere today. In healthcare, AI analyzes medical scans with superhuman accuracy, detecting diseases like cancer, diabetic retinopathy, and heart conditions. In transportation, self-driving cars use deep neural networks to interpret sensor data, navigate roads, and avoid obstacles. In entertainment, deep learning powers recommendation systems on Netflix, YouTube, and Spotify, predicting what we want to watch or listen to before we even know it ourselves. Seen AI-generated art, deepfake videos, and voice synthesis. It is also changing creativity. Deep learning can generate realistic images, music, and even human-like speech. Tools like GANs, generative adversarial networks, pit two neural networks against each other, producing outputs that blur the line between reality and imagination. Explaining the science in more detail. But how does deep learning actually work under the hood? Each artificial neuron receives input, applies a mathematical function, and passes the result to the next layer. The network's weights, numbers that determine the strength of each connection, are adjusted through a process called training. By comparing the network's output to the correct answer and minimizing the difference, the system gradually improves. This is why deep learning is called a data-driven approach. It learns patterns from examples rather than explicit programming. Visualization of a neural network learning features from an image. Deep learning networks can have hundreds of layers, each learning abstract representations of the data. Convolutional neural networks, or CNNs, excel at images. Recurrent neural networks, or RNNs, understand sequences like text and speech. Transformers, a newer architecture, power advanced language models capable of writing, summarizing, and translating text at near-human levels. Benefits and breakthroughs. The benefits of deep learning are immense. It has accelerated scientific research, improved diagnostics, enabled autonomous vehicles, enhanced security systems, and even advanced climate modeling. Tasks that were impossible or too slow for humans can now be done automatically, accurately, and efficiently. Seeing is an ethical concern, narrator. Yet deep learning is not without challenges. Training deep networks requires enormous computational resources and massive data sets, raising environmental and economic concerns. Moreover, deep learning systems can be opaque, making it hard to understand why a model made a particular decision, a problem known as the black box issue. Bias in training data can lead to unfair or discriminatory outcomes. Privacy concerns also arise when models rely on sensitive personal information. Seen visuals of AI ethics panels, regulatory discussions, and protests. Narrator. Researchers and policymakers are working to address these challenges. Explainable AI aims to make deep learning systems more transparent. Ethical frameworks are being developed to ensure fairness, accountability, and privacy. Regulation may guide how deep learning is deployed safely in society. Future-looking visuals, human-AI collaboration, smart cities. The future of deep learning is as exciting as its past. We are moving towards systems that can learn with less data, reason more like humans, and adapt to new situations. Integration with robotics, IoT, and biotechnology could redefine medicine, transportation, energy, and even education. Some experts predict that deep learning could be a stepping stone toward artificial general intelligence, machines capable of understanding and performing any intellectual task a human can. Seen montage of AI applications improving human life. Narrator. From detecting cancer in seconds to translating languages instantly, deep learning is a technology that is reshaping the world. It teaches machines not